Hello guys, hope you're doing well. When analyzing the behavior of a function at a certain point, we often want to see what value the function approaches from the left side and from the right side of that point. These are called left limit and right limit. Before we get started, make sure to subscribe to the channel and support us. First, left hand limit. The limit of f of x as x approaches a from the left means the value that f of x approaches when x gets close to a from smaller values. Look at this x-axis, and here is a, so approaches a from the left means here. For example, if a is equal 1, so x is equal, for example, 0.9 or 0.99 and so on. Okay? And the limit of f of x as x approaches a from the right means the value that f of x approaches when x gets close to a from larger values. For example, here is 1.01 or here is 1.1 and so on. Okay, so if the limit of f of x as x approaches a from left is equal the limit of f of x as x approaches a from the right, so the limit exists. So for example, the limit of f of x as x approaches a from the left is equal L, and the limit of f of x as x approaches a from the right is L. So the limit of f of x as x approaches a is L. And if they are different, then the limit of f of x as x approaches a does not exist. Okay? So let's go to the example. For example, if f of x is equal x plus 2 if x is greater than 1, and x minus 2 if x is less than 1, and 3 if x is 1. So what is the value of the limit of f of x as x approaches 1? So first, left hand limit. The limit of f of x as x approaches 1 from the left means x less than 1. So the limit of x minus 2 as x approaches 1 from the left. And now we plug in 1 for x, so we have 1 minus 2 is equal minus 1. So the limit of f of x as x approaches 1 from the right means x is greater than 1. So the limit of x plus 2 as x approaches 1 from the right is equal 1 plus 2 is equal 3. And finally, f of 1 is equal 3. Since 3 is not equal minus 1, so left hand limit is not equal right hand limit. So the limit of f of x as x approaches 1 does not exist. Okay? Even though f of 1 is 3, the limit depends on behavior near 1, not just the value at 1. Let's go another example. If f of x is equal x squared minus 4 if x is greater than 2, x minus 2 if x is less than 2, and 3x plus 2 if x is equal to So what is the value of the limit of f of x as x approaches 2? So the limit of f of x as x approaches 2 from the left means less than 2. So f of x is equal x minus 2. So the limit of x minus 2 x approaches 2 from the left. Now we plug in 2 for x. So 2 minus 2 is equal 0. And right hand limit is equal the limit of f of x as x approaches 2 from the right is equal, means greater than 2 is equal x squared minus 4. The limit of x squared minus 4 as x approaches 2 from the right is equal, if we plug in 2 for x, we have 2 squared minus 4 is 0. So left hand limit and right hand limit are equal 0. So the limit of f of x as x approaches 2 is equal 0. And f of 2 is equal 3x plus 2 is equal 3 times 2 plus 2 is equal 8. So the limit can exist even if the function has a whole or a wrong value at that point. Okay? Let's go another example. What is the value of the limit of x squared minus 4 over x minus 2 as x approaches 2? So the limit of x squared minus 4 is equal x minus 2 times x plus 2 over x minus 2 as x approaches 2. So we have the limit of x plus 2 as x approaches 2. So the limit of x plus 2 as x approaches 2 from the left is equal, we plug in 2 for x, so we have 2 plus 2 is equal 4, and the limit of x plus 2 as x approaches 2 from the right, we plug in 2 for x, 2 plus 2 is equal 4. So since left hand limit is equal right hand limit is equal 4, so the limit of x plus 2 as x approaches 2 is equal 4. So the limit of x squared minus 4 over x minus 2 as x approaches 2 is equal 4. Okay? Let's go another example. What is the value of the limit of 1 over x minus 3 as x approaches 3? This is a rational function, but notice when x is equal 3 makes denominator 0. So the left hand limit is equal x minus 3 as x approaches 3 from the left is equal, we plug in 3 for x is equal 1 over 0, but 3 from the left is equal, for example, 2.9 minus 3 is equal 0 from the left. So here is minus. So 1 over 0 is equal infinity, but 0 minus is equal minus or negative infinity. And the limit of 1 over x minus 3 as x approaches 3 from the right is equal, when we plug in 3 for x, we have 1 over 0, and 3 from the right, for example, is equal 3.1 minus 3. So 3.1 minus 3 is equal 0.1, means 0 from the right, and we have positive infinity. Okay, now look at this graph. When we approach x is equal 1 from the left side on the x-axis, we see that the function or the graph gets closer and closer to the value 4. Okay, so the limit of f of x as x approaches 1 from the left is equal 4. And on the other hand, when we approach x is equal 1 from the right side, we see the function gets closer to 2. Okay, so the limit of f of x as x approaches 1 from the right is equal to. Even we look at the point x is 1 itself, we see that the value of the function is 3. So we have f of 1 is 3. Since these two limits are not equal, the limit at x is 1 does not exist.